Now let's look at the connections of single phase VSI inverter, single phase bridge inverter. First, we are giving 15 volts DC supply for the control circuit, and from G1 K1 it's going to G1 K1 of switch 1, G2 K2 it's going to G2 K2 of switch 2, G3 K3 it is going to G3 K3 of switch 3, G4 K4 it's going to switch 4. Now the connections is same as how we did in rectifier. These two terminals should be connected. These two terminals should be connected. Then down, these two terminals should be connected. These two terminals should be connected. These two terminals should be connected. Now we are giving DC supply to the inverter. So from positive, I am giving to this terminal. From negative, I am giving to this terminal. From these two terminals, I am tapping it to transformer. Transformer 0 to 30 volts. Here I am using a step-up transformer, so the output voltage is 230 volts. It's given to bulb. Now let's switch on and look at the waveform. Now let's look at the voltage waveform across the load. Let's look at the voltage waveform across the load. It should be kept in 100 volts. You can look at the waveform. As I vary the duty ratio, the width of the pulse is varying. As I vary the pulse width, the width of the pulse is varying. Okay, the pulse, what you can see, the high value, what you can see is on period. The low value, what you can see is the off period for a switch over a complete cycle. Okay, over a complete cycle, this is the on period, remaining will be the off period. Now, one more thing what you have to do is, we need to note down T on, T off. Then we need to measure voltage across load by using multimeter in RMS mode. Multimeter in AC mode, and one terminal of voltage is going here, so I am measuring voltage across these two terminals. It's showing 170. Now I am increasing the pulse width. I kept the pulse width to maximum, so the output voltage is 268 volts. And I am reducing the pulse width. The output voltage is reducing slowly. What you have to do is, you have to note down T on, T off, then you calculate duty ratio. Theoretically, you can calculate the value of V load. Okay. You can see the tabular column. T on you can note down, T you can note down, duty cycle you calculate, V load RMS. From the reading you can take one value, you can calculate theoretically and you can cross check. And waveform at any value of T on, you have to draw it in the lab record. This is all about single phase inverter.